In this lesson, we will dive into access control lists, ACLs. ACLs are used to control and filter traffic in a network by permitting or denying packets based on specific criteria. By the end of this lesson, you will understand the basics of ACLs, how to configure them on Cisco routers, and how they impact network security and performance. Access control lists are a set of rules that dictate the traffic flow in a network. They can be used to control both inbound and outbound traffic on router interfaces. ACLs are based on packet attributes such as source-destination IP addresses, protocols, and port numbers. There are two main types of ACLs. Standard ACLs. These ACLs use only the source IP address for filtering and are numbered from 1 to 99 and 1300 to 1999. Extended ACLs. These ACLs can filter traffic based on source-destination IP addresses, protocols, and port numbers. They are numbered from 100 to 199 and 2000 to 2699. The basic syntax for a standard ACL includes three components. ACL_number. This is a numeric identifier assigned to the ACL, allowing you to reference it easily. The number can range from 1 to 99 or 1300 to 1999, depending on the network device and operating system. This specifies whether the traffic matching the rule should be permitted or denied. Permit allows the traffic, while deny blocks it. This represents the source address or range of source addresses from which the traffic originates. It can be a single IP address or a subnet expressed in CIDR notation. Standard ACLs are relatively simple and are typically used to filter traffic based only on the source IP address. They are placed as close to the destination as possible, e.g., on the router interface connected to the destination network. Extended ACLs offer more flexibility and granularity by allowing additional parameters in the rule. The syntax for an extended ACL is more comprehensive. ACL number. Same as in the standard ACL, it identifies the ACL with a unique number. As in the standard ACL, this specifies whether to allow or deny traffic matching the rule. Indicates the network protocol for which the rule applies, e.g. TCP, UDP, ICMP, etc. Specifies the source IP address or range from which the traffic originates. Source wildcard. This is used to specify a wildcard mask for the source IP, indicating which bits in the source address should be considered for matching. Specifies the destination IP address or range to which the traffic is directed. Destination wildcard. Similar to the source wildcard, this specifies the wildcard mask for the destination IP. Specifies the destination port number or range of port numbers for the specified protocol, applicable for TCP/UDP. Extended ACLs provide finer control and allow you to filter traffic based on various parameters, making them more suitable for complex network security policies. It's important to note that the exact syntax and options for ACLs may vary depending on the networking equipment and operating system being used. However, the fundamental purpose remains the same: to control and filter network traffic based on specified rules to enhance security and network performance. Destination wildcard, source wildcard, ACL number. Let's create a standard ACL that denies traffic from the source, IP 192.168.1.10. The first line creates a standard access control list, ACL, with the number 10. The ACL is designed to deny traffic from a specific source IP address, which is 192.168.1.10. In other words, any traffic that originates from the IP address 192.168.1.10 will be blocked or denied by this ACL. This line sets up the first rule in the ACL. The second line adds a second rule to the same ACL, number 10. The new rule is designed to permit all other traffic that does not match the previous deny rule. In this case, the keyword any is used, which means it will allow any traffic from any source that hasn't been explicitly denied by the first rule. This line creates an extended access control list, ACL, with the number 101. The ACL is designed to permit TCP traffic with a specific set of conditions. Permit TCP. This indicates that we are allowing TCP traffic. 192.168.1.00.0.0.255. This is the source IP address range. It specifies the subnet 192. 168.1.0.24, meaning any IP address from 192.168.1.0 to 192.168.1.255, inclusive. 10.0.0.00.255.255.255. This is the destination IP address range. It specifies the subnet 10.0.0.0.8, meaning any IP address from 10.0.0.0.0 to 10.255.255.255, inclusive. EQ80. This specifies the destination port number, which is port 80. Port 80 is the standard port for HTTP traffic. In summary, this line allows TCP traffic from any device within the subnet 192.168.1, 0.24 source to any device within the subnet 10.0.0.0.8 destination on port 80, which effectively permits HTTP traffic from the specified source subnet to the specified destination subnet. The second line adds a second rule to the same ACL, number 101. The new rule is designed to deny any IP traffic, regardless of the protocol, from any source to any destination. In other words, this line blocks all other types of traffic that do not match the first rule. To summarize the ACL's behavior, TCP traffic from the source subnet 192.168.1, 0.24 to the destination subnet 10.0.0.0.8 on port 80 is permitted. All other types of IP traffic from any source to any destination are denied. When the router evaluates a packet against this ACL, it will check the rules sequentially. If the packet matches the conditions of the first rule, it will be permitted. If it doesn't match the first rule but matches the second rule, because it is IP traffic, it will be denied. The provided commands are used to apply an access control list, ACL, to a specific interface on a router. Once you have created the ACL with the desired rules, you can then apply it to control the flow of traffic entering or leaving that particular interface. Let's break down the commands step by step. In the first command, you replace interface name with the name of the interface to which you want to apply the ACL. For example, it could be Fast Ethernet 1 or Gigabyte Ethernet 1.0, depending on the router's interface naming convention. By entering this command, you are moving into the configuration mode specific to the chosen interface. In this mode, you can configure various settings and apply specific configurations that only apply to that interface. In the second command, you replace ACL number with the numeric identifier of the ACL you want to apply. This should be the same ACL number that you used when creating the ACL using the access list command. The in-out parameter determines the direction of traffic to which the ACL will be applied. In. This keyword applies the ACL to incoming traffic on the specified interface. It means the ACL will be used to filter traffic as it enters the router through the chosen interface. Out. This keyword applies the ACL to outgoing traffic on the specified interface. It means the ACL will be used to filter traffic leaving the router through the chosen interface. When you apply the ACL to an interface, the router will inspect each packet coming in or going out of that interface and check it against the rules defined in the ACL. If the packet matches a rule in the ACL, it will be either permitted or denied based on the rule's action, e.g., permit or deny. It's important to note that you can apply different ACLs to the inbound and outbound directions of an interface. This allows you to have different filtering rules for incoming and outgoing traffic on the same interface, tailoring your network security and traffic management to your specific requirements. CUL number. Interface name. The Show Access Lists command is a helpful tool for troubleshooting access control lists, ACLs, on a router. When you implement ACLs to control and filter network traffic, it is possible to encounter issues where unintended traffic is being blocked or allowed. The Show Access Lists command allows you to inspect the ACL configurations and view the hit counts for each rule, helping you identify and resolve any problems. The output will typically include information such as ACL number, the numeric identifier assigned to the ACL, line number, the sequence number of the rule within the ACL, rule details, the details of each rule such as permit, deny, protocol, source, destination, port, etc. Hit count, the number of times each rule has been matched by traffic. By examining the output of Show Access Lists, you can check whether your ACL rules are being used as intended and whether traffic is being permitted or denied correctly. If you notice that certain rules have a low or zero hit count, It might indicate that those rules are not being matched, and you might need to review your ACL logic to find and correct any issues. This command is especially useful during troubleshooting, as it provides real-time insights into how your ACLs are behaving. It allows you to verify that traffic is being filtered according to your expectations and helps you identify any misconfigurations or unintended consequences of your ACL rules. Best practices for access control lists, ACLs, are guidelines that network administrators follow to optimize the use of ACLs and ensure network security and performance. Let's delve into the 3 best practices mentioned. 1. Place ACLs as close to the source as possible. When implementing ACLs, it's generally a good practice to place them as close to the source of the traffic as possible. In the context of a router or network device, this means applying the ACL on the interface closest to where the traffic originates. By doing so, you minimize unnecessary processing of traffic that does not need to traverse the entire network before being filtered. For example, if you want to block certain traffic coming from a specific subnet, applying the ACL on the ingress interface of the router connecting to that subnet will prevent the traffic from entering the internal network altogether. This approach is more efficient than applying the ACL on an interface closer to the destination, as the traffic would have already consumed resources and bandwidth to reach that point. 2. Use standard ACLs for simple filtering requirements and extended ACLs for complex filtering needs. ACLs come in 2 main types, standard and extended. Standard ACLs are simpler and can only filter based on the source IP address, whereas extended ACLs offer more flexibility by allowing filtering based on various parameters like source and destination IP, protocols, port numbers, etc. The best practice is to use standard ACLs when simple filtering is sufficient. For example, if you want to block or permit an entire subnet's traffic, a standard ACL could be suitable. However, for more complex requirements like filtering traffic based on specific protocols, port numbers, or both source and destination addresses, extended ACLs are the better choice. Using the appropriate type of ACL for each scenario improves the efficiency of the filtering process and makes the ACLs easier to manage and maintain. 3. Regularly review and update ACLs. Networks are dynamic environments, and security requirements may change over time. Therefore, it's crucial to regularly review and update your ACLs to ensure they align with your network's current security policies and needs. Periodically, auditing your ACLs allows you to identify and remove any obsolete rules, ensuring that you are not unintentionally allowing or blocking certain traffic. It also helps you to stay on top of any new security threats and adapt your ACLs accordingly to maintain a strong defense against potential risks. By following these best practices, you can effectively use ACLs to control network traffic, enhance security, and optimize network performance. Always consider your network's specific requirements and consult security best practices while implementing ACLs. We hope this video helped you on your journey towards becoming a cybersecurity expert. Remember to subscribe to our channel and turn on notifications so you never miss out on our latest content. And if you found our videos helpful, please give us a thumbs up and share them with your friends and colleagues. Don't forget to check out the links and description for our Anki flashcards and to donate to St. Jude Children's Research Hospital. Your support can make a real difference in the lives of those in need. Thanks again for watching, and we'll see you in the next video.